Welcome to New Findings of the Universe. Today we are going to explore a question that challenges everything we believe about our past and about our place on this planet. A question that sounds simple, but carries enormous implications. What if we were not the first advanced civilization on Earth? We grow up believing that humanity represents the peak of evolution. That we were the first to build cities, the first to harness energy, the first to change the climate of an entire planet. But when we step back and look at the true age of Earth, that certainty begins to feel fragile. Our planet is more than 4.5 billion years old. Modern human civilization occupies only a microscopic moment within that immense span of time. The Earth is not forgetful. Every major event leaves a trace. Asteroid impacts, volcanic eruptions, climate shifts, all of them are recorded in layers of rock, ice, and sediment. The planet keeps a memory far longer than any civilization ever could. And this leads to an unsettling thought. If an advanced civilization existed before us, would the Earth still remember it? This idea forms the foundation of what scientists call the Silurian hypothesis. It is not science fiction. It is a serious scientific question. It asks whether an industrial civilization could have existed millions of years ago, and then vanished so completely that only subtle traces remain. Imagine a civilization that lasted thousands of years. It extracted resources, altered ecosystems, and changed atmospheric chemistry. Over millions of years, its cities would crumble. Its technology would corrode. Its bones would disappear. But certain chemical fingerprints could survive, locked deep within the geological record. We already know this is true because our own civilization is doing exactly that. Plastics, carbon signatures, radioactive isotopes, all of these will remain long after humanity is gone. Future scientists will see them clearly. So the real question becomes unavoidable. Are there similar fingerprints hidden deep in Earth's past? In this journey, we will explore strange geological signals, unexplained extinctions, mysterious chemical anomalies, and the gaps in the fossil record that refuse to tell a complete story. Stay with us. And if questions like these ignite your curiosity, subscribe now to New Findings of the Universe. This is only the beginning. To understand why this idea is even possible, we must understand how Earth records history. Geological layers function like pages in an ancient book. Each layer captures information about temperature, atmosphere, chemistry, and life at a specific moment in time. In the late 20th century, scientists discovered a thin layer of rock enriched with iridium that marked the extinction of the dinosaurs. Iridium is rare on Earth, but common in asteroids. 65 million years later, that single catastrophic event is still unmistakably visible. That discovery changed how we think about deep time. It proved that brief events can leave permanent signatures. And once that door was opened, another question followed naturally. If a single asteroid impact left such a clear trace, what would thousands of years of industrial activity leave behind? Every advanced civilization consumes energy. Energy use always changes the environment. It alters atmospheric chemistry, ocean composition, and biological systems. Even if buildings vanish, the planet itself is transformed. The challenge is recognition. We know what modern industry looks like because we are living inside it. But a previous civilization might have used technologies we cannot imagine. Materials that do not resemble steel or plastic. Energy systems that leave unfamiliar traces. To us, those remnants might look natural simply because we do not know what to look for. Time also works against us. Tectonic plates recycle the crust. Continents drift. Oceans swallow land. What feels permanent today is temporary on geological scales. Most surface evidence would be erased. Yet some signals persist. Isotopic ratios. Atmospheric changes. Metallic dispersions that do not behave like natural processes. And here is the unsettling part. Scientists have already found some of these anomalies. None of them prove an ancient civilization. But not all of them fit comfortably within existing explanations either. They remain open questions, and science advances by asking uncomfortable questions. If you want to keep exploring the edge where known science meets the unknown, subscribe to New Findings of the Universe. There is much more beneath the surface. One of the strangest records of Earth's past is the fossil record itself. It should show gradual, continuous evolution. Instead, it looks fragmented. Entire chapters appear to be missing. The most famous example is the Cambrian explosion. Over 500 million years ago, complex lifeforms appeared suddenly. Eyes, shells, nervous systems, all emerging within a relatively short geological window. Before this event, life remained simple for billions of years. Then complexity surged almost overnight in geological terms. Traditional explanations involve oxygen levels and genetic innovation. Yet the speed and scale of the change remain deeply puzzling. Now imagine another possibility. Imagine a prior civilization that altered the environment on a planetary scale. Chemical changes, indirect genetic pressures, ecological engineering. When that civilization disappeared, it left behind conditions that triggered an explosion of biological diversity. This does not replace existing theories. It expands the field of possibility. Science progresses by asking whether alternative explanations could also fit the data. Mass extinctions raise similar questions. Earth has experienced several major extinction events. Some are clearly linked to volcanism or impacts. Others show patterns that are harder to explain. Selective survival, rapid collapses, unusual recoveries. A collapsing technological civilization could produce similar effects. Pollution, climate disruption, habitat destruction. When the civilization disappears, life eventually rebounds, but the record is fragmented. These ideas do not claim certainty. They invite investigation. And investigation is the foundation of scientific progress. If you are drawn to questions that challenge what we think we know, subscribe to New Findings of the Universe. The story of Earth may be far older and stranger than we ever imagined. One of the clearest markers of industrial activity is carbon chemistry. When fossil fuels are burned, they release ancient carbon with a specific isotopic signature. That signature becomes embedded in sediments and ice. Strangely, certain ancient geological boundaries show carbon signatures remarkably similar to those produced by industrial combustion. One example appears around the Permian extinction, the largest die-off in Earth's history. The scale of carbon release suggested by these layers is immense, comparable to burning all known fossil fuel reserves in a short span of time. The standard explanation involves massive volcanic activity, and that explanation is reasonable. But the pattern itself remains unsettling. Metallic microparticles provide another clue. Today, industrial processes create tiny metal spheres formed at extreme temperatures. These particles spread globally through the atmosphere. Similar particles have been found in ancient sediment layers, distributed across continents. Would natural processes produce them? Possibly, but repeated patterns raise questions that deserve closer study. There are also unusual radioactive isotope ratios that resemble nuclear processes. Natural nuclear reactors exist, as discovered in Africa. But some signatures do not fully align with known natural mechanisms. This does not mean ancient nuclear wars occurred. It means there are signals that challenge simple explanations. Science does not move forward by ignoring anomalies. It moves forward by investigating them carefully. If you want to explore science without fear of asking difficult questions, subscribe to New Findings of the Universe. The deepest mysteries are still waiting. Material durability offers another unsettling perspective. Plastic, for example, will likely be humanity's most enduring legacy. Long after our cities crumble, microscopic plastic fragments will remain in sediments. Now consider this. In some ancient sediments, scientists have identified particles that behave like synthetic polymers. They resist degradation. They display complex molecular structures. and they appear in layers far older than humanity. Are these misinterpretations? Unknown natural phenomena? Possibly, but their global distribution and repeated appearance raise legitimate scientific curiosity. A previous civilization may have developed materials far more advanced than ours, materials designed to endure. Over millions of years, such materials might be mistaken for unusual minerals. The absence of visible ruins proves nothing. Time erases nearly everything. Only the deepest fingerprints remain. If a civilization existed 100 million years ago and lasted 10,000 years, its presence today would be nearly invisible, except for subtle chemical echoes. The Silurian hypothesis does not assert truth. It asserts possibility, and refusing to explore possibility limits discovery. If this perspective fascinates you, subscribe to New Findings of the Universe. Earth's past may be far richer than we assume. Ice preserves history with extraordinary fidelity. Antarctic ice cores contain tiny bubbles of ancient air, preserving atmospheric snapshots across hundreds of thousands of years. Within these records, scientists observe abrupt spikes in greenhouse gases. Some align with known climate events. Others remain unexplained. The patterns resemble what modern industrial activity produces. Rapid increases, sustained plateaus, then declines. Some are natural cycles. Others do not match existing climate models cleanly. Certain layers even contain compounds that should not exist. Naturally, again, not proof, but signal. As anomalies accumulate, dismissal becomes harder. If ancient civilizations existed, they may have also reached beyond Earth. Space preserves artifacts far better than the planet's surface. The Moon, orbital space, and deep space may still hold evidence. The search is just beginning. If you want to follow these investigations as science evolves, subscribe to New Findings of the Universe. The unknown is closer than you think. Perhaps the most disturbing aspect is the repeating pattern. Emergence, expansion, planetary alteration, collapse, recovery, again and again. This pattern mirrors our own trajectory. The Silurian hypothesis may not be about the past alone. It may be a warning. Civilizations that master technology without sustainability leave scars that last, meal for millions of years. If we fail to learn, we may become just another anomaly embedded in stone. Future intelligences may study our era through microplastics and isotopes, wondering who we were. The past is not just history, it is reflection. If this thought resonates with you, subscribe to New Findings of the Universe. Understanding yesterday may be the key to surviving tomorrow. We have reached the end of this journey, but not the end of the question. What if we were not the first civilization on Earth? We may never know with absolute certainty, but science does not require certainty to move forward. It requires curiosity. The Silurian hypothesis does not undermine science. It strengthens it. It reminds us not to assume that what we know is all that exists. Earth is ancient. Humanity is young. Believing we are the first at everything may be our greatest mistake. Perhaps we walk on the erased footprints of others. Perhaps we are not alone in history. And perhaps, if we are willing to learn, we do not have to share their fate. If you want to continue exploring the deepest mysteries of the universe and our planet, subscribe now to New Findings of the Universe. The past is still speaking. The question is whether we are ready to listen.